Let's start by understanding the question before jumping into the math. We're told that there was a fault in the Earth's crust. That means a crack or fracture where two blocks of rock slipped past each other. The slip along the fault, which we call the dip slip, was 17 meters. But this fault isn't vertical. It's tilted at an angle of 52 degrees from the horizontal. At the same time, we know there was a horizontal shift of 22 meters due to this fault movement. Now we need to calculate two things: the total movement, how far the ground actually shifted in space; the vertical displacement, how much higher or lower one side of the fault moved compared to the other. First, imagine a right-angled triangle. The horizontal leg of the triangle is the horizontal slip, 22 meters. The slanted side going up the fault plane is the fault slip, 17 meters. The actual movement, the net shift from point A to point B, is the hypotenuse of this triangle, so we'll use the good old Pythagorean theorem to find the net movement. The formula for the net movement is AB squared equals AD squared plus AC squared, where AB is the total movement, what we want to find. AD is the slip along the fault, 17 meters. AC is the horizontal shift, 22 meters. Let's do the math. 17 squared is 289. 22 squared is 484. Add them up. 289 plus 484 equals 773. Now take the square root of 773. That gives us 27.8 meters. So the total movement of the ground is 27.8 meters. Next, let's figure out how much of that movement happened in the vertical direction. Since the fault is tilted at 52 degrees from the horizontal, the vertical component comes from projecting the dip slip onto the vertical direction. Take a look at the triangle on screen. We know that. The hypotenuse, labeled AD, is 17 meters. The angle is 52 degrees, and the vertical displacement is the side opposite the angle. So, which trigonometric function connects angle, opposite side, and hypotenuse? That's right, the sine function. Now let's write it out. In our case, sin, 50 is 2 degrees. Vertical, 17. We already know that the sine of 52 degrees is approximately 0.788, rounds to about 13.4 meters. So the vertical displacement is 13.4 meters. That's how far the land moved vertically during the earthquake.